Hello and welcome back. My name is Steven and I'm here to teach you how to program in C# on .NET Framework for Windows platforms. If you haven't checked out episode 1 of this series, I really recommend you do that. It gets into a little bit of programming, but primarily focuses on how to use Visual Studio 2019 in its most basic forms. It'll really kickstart your way into using a .NET language. Let's jump right into primitives. What is a primitive? A primitive is a term used for the most basic variables available in any given programming language. You'll find this in Java, C#, C++, and literally hundreds of others. Objects are abundant in C#, and you'll hear the term object thrown around almost arbitrarily. It's what everything is considered in this object-oriented programming language, or OOP programming language. Sounds really funny because it's OOP, but it's really key to understand objects. We'll get into that later. Objects are made up of these primitives. We're talking about integers. We're talking about strings, characters, and so on and so forth. So let's break down what each of those actually is. This is the program that we left off from episode 1. It's a program that takes a value from a text box and adds it to a list. Really simple, really straightforward, but it shows just how easily and quickly you can jump into making a user interface or something that anybody could use. I'll give you a quick demonstration of what it does currently when we start it up. Here's our text box. We're going to throw in some text. We're going to hit our add value button, and it's going to add it to our list box. Fantastic. Now, say we want to add a value to the list box that isn't what we entered into that box. What if we want to enter in a number every time we click the button? Well, that's pretty simple. I'm going to remove some code that we wrote last week, and I'm going to save my file. I habitually save my file. Control S is like second nature for everything that I've done. And not just in coding, but in files in general. But in coding even more so. Because it's really easy to make a mistake where you accidentally add too much or you accidentally delete too much. So let's jump into our primitives. The most quintessential one, which we're going to start with, is a string. What is a string? A string is a list of characters. That's all it is. If you read novels or news articles or Stack Overflow for fun or what have you, a string is a value of alphanumeric or symbolic characters. So if you're reading a book, it's what you would read from the pages of the book. If you're reading a news article, similar. Anytime you read Twitter or Instagram posts or Facebook, anytime there's text, that's a string. It's really straightforward. It's the easiest one to wrap your mind around. The only one I can imagine would be easier is the integer. The integer is a basic whole number. You may remember this from your math classes, you may not. I haven't taken a math class in a long time, and so remembering that we learned about that in school blows my mind a little bit. Integers are whole numbers, 0, 1, 2, 3, 4, 5, on through infinity. Whole numbers don't have a decimal place other than a referenced one. In a programming language, you will never see an integer followed by a .00, like you would handle money. Something like that. That is a different primitive that we're going to get to in a moment. Integers would be something like that. Integer I equals 0. And I'm declaring variables here, but that's not important. We will cover that. But right now, it's really important that you grasp that an integer type allows for whole numbers only. Next up is the one I was just referencing. A double. A double is a number that looks like that. So we can do double I equals that, and that is completely valid. Next up, we're going to use a Boolean. which is a really funny name. Boolean, which when you're declaring a variable is shortened to bool, is a value that is either true or false. A Boolean value is used everywhere and can be translated from ones and zeros to true and false pretty universally. So if I were to say Boolean is working equals false, that's valid because we're setting this variable equal to false. More on variable assignment later. Right now, it's really important to understand if somebody says, I really need to know if this thing is real or if this comes in, do this thing. A Boolean value is what determines that. Conditionals will be probably the next episode because there's not a ton you can do without understanding conditionals and loops. And I think that'll be an episode in and of itself. Let's get into variables. And I know I said we would get into it later, but it's really important to understand how variables are used. If you remember high school math at all, algebra specifically, you should remember that X was introduced, or pre-algebra maybe. You started using equations with variables like y equals mx plus b, or yeah, I can't remember half of my algebra from high school. But that's okay. Google is still my friend. So, variables in programming work very similarly to that. Essentially, a variable stands in as a substitute for a value that you may or may not know. In the case of y equals mx plus b, we may want to find out what y is equal to. So let's start with something like that, familiarly. I'm going to start with a comment. And I know I haven't covered comments yet, and I will. Actually, maybe it's best to just cover them now. Comments are code that, or are parts of your code file that don't actually get compiled. They don't affect your program at all. You can write anything you want to, and it doesn't throw syntax errors because it's just completely ignored by the computer. It's a really great way to make notes for yourself, to make to-do lists and things like that. The way that I use them, generally, is to let other programmers know some of the confusing parts of the code that I've written. To-do lists are also a big part of it. So you can write in Visual Studio a // to-do, T-O-D-O, and colon. This is a list of things to do. It's really easy from there to go to your view and task list, Control WT, and it will show you exactly where you want to go. You can also double click your to-do list item and it will jump you to that line of code in the file that it appears in. To make a comment, a single line comment, you will do // like I've shown here. If you want to do multi-line, you can just end it like that. You start it with /*, then you can jump down as many lines as you want to, and then end it with a /. It's as simple as that, honestly. There's one other kind of comment in C# called an XML documentation comment. We're not going to get into that right now. That's more advanced. We'll get into that once we've covered methods and functions, I think. That'll be a more appropriate use of that kind of comment. For now, I want to write out my equation that we're representing here. And yeah, shame me if I look down at my keyboard. I can type without looking. Not my strong suit, though. So y equals mx plus b. Say our m box. Oh, do I have... Interesting. I don't know why m box showed up. But let's do an integer, which is a whole number, remember, named m equals 2. That's a variable. That's how you declare a variable. Declare means to set it aside in memory. Essentially, what you're doing is saying, I've got this thing. It's called m, and it is equal to the value of 2. if you imagine just like in math class, x equals 4, that's all we're doing here. If you look at just the m equals 2, that's exactly what we've done. The only difference is we've told the compiler, we've told Visual Studio in this case as well, that the data type is an integer rather than a string or a variable of type char or boolean or what have you. Characters, by the way, are another very useful variable, and I know I didn't mention them before. They're used sporadically throughout code bases, but a char is a single string value. So it's going to be a character of C, or S, or M, or B, or X, or Y, etc. It's only one though, and I'll show you how to declare those as part of this whole variables exercise. Anyway, back to our int m, the most beautiful variable I have ever created, because it's simple and there's nothing complicated about it. So it's an integer, it's a whole number, and I've named it m. So basically I don't have to retype 2 everywhere. If I had 30 equations and they all used the value 2, and those could all be changed at any given point in the program, I would set those 2's to a variable like m. I also can't stress enough that it's important to name your variables very explicitly what you want them to be or what they do. I'll show you a little bit more of a complex sample in another code base that I've been working on, because I think it's important that you see how it can really easily get out of hand if you just continually name your variables m or m2 or x5 or something like that. So int2, we're going to say int x equals 4 and int b equals 10. So if then if this is going to be an integer, which it should be, we're working with all whole numbers, let's do int y equals mx plus b. And mx, as you'll notice, does not actually work. And that's because it doesn't know how to interpret this. Is this supposed to be a variable? Is this supposed to be a name of something else? Is this a baked-in object? It isn't. It's a mathematical function we're doing here. So remember that you may have to explode it out. Really straightforward. So what we're going to do here is we're going to set a breakpoint. Now, the first few episodes of this series are going to be very heavy in learning tools because, honestly, I have an awful memory, and remembering what I do step by step on a daily basis can be kind of difficult. So, as I come across things, as I said in the first episode, I will stop what I'm saying and what I'm doing, and I will almost over-explain, if not fully over-explain what I'm doing. A breakpoint is important because when you're debugging, which we'll get into in a separate episode, that is a very important episode. Do not miss it if you are a beginner in programming. A breakpoint allows you to stop your code right on the spot and see what's happening. And it also lets you step through your code line by line so that you can figure out why something's not working the way you expect it, or why something works when you don't want it to, or when you don't think it should. So, very pivotal piece of technology is this breakpoint. We could also have this show up in the console. We could also have this show up as a pop-up. We could have it do a lot of things. But in this case, I think it'll be important to just show you what a breakpoint is and how to use it. So we're going to go start. And it should have broken. It should stop and show us just this code and let us see what's going on. But remember, we've coded this equation and the variables in our click handler. So it'll only really happen when we click our add value button. So let's do that. Here it is. We've broken, quote unquote, the code. That means that we've stopped the execution of our code. We've stopped our program from going any further until we tell it to go forward. Breakpoint is a stop sign at an intersection of very fast computational code rendering. M equals 2, X equals 4, B equals 10. When you are in break mode like this, you can hover over your individual variables to see the values that you have currently set for them. We have our equation down here, and I should be able to hit the step forward or step over button. On the keyboard it is F10. Great. So what does y equal? Well, let's hover over it and see. 18. Let's just make sure that our math is correct. It should be, but it never hurts to double check. So m times x should be 2 times 4, should be 8, plus 10, RB, which is 18. Perfect. That's exactly what you want to see. Compilers are very good at math. Very, very good at math. But for this familiarity exercise, you now have something to draw back to your old school days. Even if your old school days were 2 semesters ago, or I guess that would be a little bit redundant, wouldn't it? Maybe your old school days are a couple of years ago, or maybe it's only a couple of months ago that you graduated. Well, that's fine. It can still be a little bit difficult to remember things that you've learned in school. Y equals mx plus b, used everywhere. I mean, it's a basic graphing function. And almost everybody that's outside of 17 or 18 years old knows what y mx plus b is, even vaguely. In this case, it's something that you can draw back to and say, oh, hey, a variable works just the same way as it did in algebra when I was in high school, or pre-algebra, or what have you. So those are variables. Those are some primitives. And I know I promised to show you characters. So let's show you what a string and a character is. Fun fact, the last episode that I did, if you haven't seen it, again, link in the description below. Recommend it. I printed out to that list box. I added to the list box, this box here, a value. It was Steven, exclamation point. It was even at the beginning of this episode. That is a string value. My name is a string value with an exclamation point or not. So if my name is Steven Starlin, which it is, then I would declare it in a string like this. The quotes tell the compiler and Visual Studio that this is a string value. If I were doing my initials though, my first initial, which should be S, and I wanted to do it in a string, or if I could do it in a string, but if I wanted just the first value, I would do a character, a car value. And that uses single quotes. If you were to try to do this with a string and use those single quotes, you will get an error because it cannot implicitly convert a type character to a type string. We'll get into casting in another episode. Casting, for a quick overview, is converting one variable type to another. So an integer to a string, a double to a string, a character to a string. And it doesn't just go to string, that's just the most basic and easy casting you can do. That is pretty much the basis of all of our variables, our primitives anyway. We'll get into more complex objects and variables later on, but I don't think I need to overload you with this. This is a lot to take in. If you really want to play around with this, I do recommend it. I can include some of these files in a zip file or on a web server somewhere if that's what you would like. This is a really basic solution. I don't really feel like I need to provide the solution. If you haven't seen the first episode, I know I've said it a bunch. It's really important that you understand the very basics of what I did from the last episode. It leads into this perfectly and helps you set up the project that we're going to be working with moving forward. It's very basic for the time being, but it could get very complicated as we get into topics like multi-threading and dynamic user interface generation. I have one final point that I'd like to cover, and that is in the instance that you are working on a larger piece of software. I mentioned earlier that variables can get very, very out of hand. This is a program that I'm writing for a friend of mine who developed a board game and is currently developing the board game. It's not released yet. During this whole unfortunate epidemic, the socialite friends of mine and I, who I am also an extrovert, are finding it difficult to play the games that we loved during our game night. So I decided to work on developing a digital version of his alpha tabletop game called Crit. So this is some of the code, and I don't expect you to understand any of this. Trust me, I don't. It's not that it's overly complicated, it's just a little bit further down the line of development than understanding primitives. But what you can see here is I have a variable. This is a variable of type game. It is a custom variable. It is a custom object. It is not a primitive, but it is a variable called current game. Current game, I could very easily name it X, and you would have no idea throughout the entirety of the rest of the program what the heck X is. If you look over on the right hand side, the gray is everywhere that the code was changed due to my renaming function. Or maybe it was a green. Sorry. I can't stress enough how important it is that you don't do this. It's not just rude to leave this kind of naming convention poorly drawn out and in your code for somebody else to find, but it also makes your life and management's life very difficult, because there can be a lot of different contexts in which that variable is used. In this class, a class in this case is a file that we have open that we are editing, not the class that I am teaching. But in this particular file, X might mean current game, but you might take X and set it to a player object or an integer object in another class. And that would monumentally confuse anybody trying to look at your code base. And if that's something that you're looking to do, I would really advise against it, and I would heavily seek other kinds of encryption methods. Higher level concepts to try to understand for a basics class, I know, but I really want to convey and bring it across the table that it's very important that you don't allow yourself to misname your variables. There's no excuse to not name your variables something ridiculously long or specific, like this is the current game object, use this for save state. Because you have IntelliSense. You can start typing the name. I mean, IntelliSense is this thing. I can start typing the name, and it will show me all of the objects that I have in my class that I can reference from that beginning text. It is a fuzzy search of object names, and it's beautiful. You start typing, it comes up with what you want. You can navigate with your arrows and hit enter to autocomplete, and then you can access your subproperties from there. We'll get into more complex objects later on, but I don't feel as though we need to do it right now. We've covered variables, we've covered primitives. It may sound like there wasn't a whole lot covered in the class for this session, and I understand that, but I would let this stew. Ruminate on what primitives are and how they can be applied, because you may find that pretty much everything that you do in your everyday life could be defined by some sort of basic variable. How many eggs are you buying? How many tires do you need for your car? How much money did you make in your paycheck this week? How did I sign my name? It sounds ridiculous, but the difference between Bill S. Preston or Theodore Logan or something along those lines is really, really different. And it's really just a variable. I mean, your name versus my name, I'm sure, are fairly different, unless you've stolen my identity, in which case I would like to talk to you in my office after the pandemic. Might be a little far for a joke. So, thanks so much, and I hope you learned something. If you have thoughts on where I should go in the future with this, or if you want me to start another series on programming, I'm definitely taking suggestions, and after this one is done, I'll focus on another programming language or another technology. So, until next time, thanks, and have a good one.